built this circuit, inverting mode, operational amplifier, input resistance of 10 kilo ohms R1, feedback resistor of 100 kilo ohms, supplying it with 15 volts, positive and negative. We change Vin by altering this potentiometer. So Vin is altered by changing the resistance on the potentiometer. And remember that operational amplifiers are designed to amplify the voltage, to amplify the input voltage. So whatever the input voltage is here, the output voltage is going to be larger by a factor that is dependent on the gain. And the gain is dictated by these values here, by the values of RF and R1. So as Vn is increased, Vout increases. Now Vout increases, but it doesn't continue to increase as we saw from our results there. Vout increases until you approach plus or minus Vs. So this value Vs, the supply voltage that we're putting in here, we know is plus 15, minus 15, and with our 0 volts laying across the bottom here. So as it begins to approach that value, it begins to level out. So until you approach plus or minus Vs, at this point, stops increasing. So it stops increasing, and from your results there you should see that it's probably around about 13.7 maybe, around about there. The voltage stops increasing. The output voltage has reached its maximum. And we say that the op amp is saturated. So most of the time the output voltage is increasing with the input voltage, but once it reaches a point that's close to the supply voltage, in this case it's 15, once it starts getting there it begins to level out, it stops increasing, so the output voltage has reached its maximum value, and its maximum value occurs when the op amp is saturated. Now that value is usually about 85% of the supply voltage here. So that kind of ties in with our results. If we look at the graph that we plotted, we had the output voltage against the input voltage, and our graph comes out looking something like this. If we look at these values, this is around about 13.7. This is around about plus 13.7. And if we bring this value down here, then this will come in at around about 1.3 on either side there. So that's really the last value that it can reach without exceeding the supply voltage, because that's what's happening there. The output voltage cannot exceed, be greater than the supply voltage that is supplied to the op-amp. So what it does is it saturates. So the output voltage, VO, cannot be greater than plus or minus Vs. So it cannot be greater than plus or minus 15 in this case. The maximum output voltage, sorry, that should be an op-amp can have, is usually approximately 80%, 85% of Vs. So an op-amp won't continue to increase the output voltage. There will be a point where it approaches Vs, whether it's plus or minus Vs. And remember, whether it's plus or minus depends upon your input, whether that's been plus or minus. There will be a point where it starts to level out, and that's usually at about 85% of the supply voltage. It can never be greater than what the supply voltage is. When it gets to a point that is going to be greater than supply voltage, then the op-amp will saturate to make sure that that voltage doesn't go above that level.